Okay, so today our target, I will be able to find decimal number quotients using fractions as division. And remember that word quotients. It's a vocabulary word maybe from 4th grade. You can think about what it means. I'll tell the answer in a second if you want to pause the video. Okay, quotient just means the answer to a division problem. So please write the target down, pause the video. Okay, so each of these slides are going to have a W up in the corner. That means we need to write it into our notebooks. Here's an example of what we mean by fractions as division. So if you look in the top left of the slide, we have the fraction 3/5, or 3/5. That fraction bar can also be read as a division sign, and we want to read it like that today for our purposes. So 3/5 is the same as 3 divided by 5, which we know can also be written like this. But we want to start to write it like long division, like here, 3 divided by 5. So that's the first step I have written below here in yellow. We rewrite the fraction as long division. Just be careful. Make sure that first number, it's actually called the dividend, the 3 in this case, goes inside the little house. The 5, the divisor, goes on the outside. Remember, the number being divided or split apart goes inside. So when you say 3 divided by 5, put that 3 inside the division bar. And the other step here in purple, insert decimal point and zeros with the dividend. Okay, remember this dividend is the one inside the house. So decimal point means right after the 3. And we'll just insert a couple zeros. Remember, 3 is the same thing as 3.00, but we're going to need those decimal places because we're going to have a decimal number. Now we just carry out long division. Okay, 5 goes into 3, it can't. It's too big, so there's 0 5s that go into 3. The next point, you have a decimal, so you have to carry that decimal up, okay, into what's going to be your quotient. Now, this is a little tricky. You got to make sure, since 5 can't go into 3, you can read the next digit together. So it's like you're looking at 5 into 30. 5 goes into 36 times. And then you just do your long division steps. You have no remainder. So if you want to put a 0 up there, it's the same thing. Doesn't really matter. So we see that 3/5 decimal version of it is going to be 0.6. Okay. Once you have no remainder, then you can stop doing your division. Here's another example. We want to convert this fraction to a decimal. 7/8, or like we said, that's the same as 7 divided by 8. But we want to make sure we write it like long division. 7 divided by 8. And we just do our steps we did before. Decimal point, 2 zeros. Start to division, 8 into 7. It's too big for 7, so it's 0. You bring up your decimal point. Now you're reading 8 into 70. This is why it's important to know your multiplication table. 8 goes into 70 8 times. Bring down your 0. 8 goes into 67 times. Now here's the important part. We still have a remainder. That means we still have to keep going. We ran out of zeros, but we can just keep inserting zeros into our dividend, as many as we need, because think about it, if you keep adding zeros or inserting zeros to the right side of the decimal, it's not changing the value of 7. It's still just 7 no matter what. Okay, so we can keep using those zeros to help us do the division. Now we finally have no remainder because 8 goes into 40 5 times. So we would say 7/8 is the decimal, 0.875. And we'll get into this other topic in a couple weeks, but we'll eventually go from fractions to decimals to percentages. And percentages is what your grade is based on in classes. So we would actually figure out how to convert 7/8 to the decimal, and this percentage is actually 87.5%. and your teacher would probably round it up to 88%. So it's like a B. But don't worry about that part now. We'll get to that in a couple weeks. Here's a definition we need. Something called a terminating decimal is a decimal that ends. That's what the word terminates means. Sometimes if somebody is terminated from a job, it means they're fired, their job has ended. Or we have Arnold Schwarzenegger down there in the right corner as the Terminator. He ended, I guess he ended people in a sense. He was an alien robot from another planet. Not a good guy. An example of a terminating decimal. Let's just do 3/4. That's 3 divided by 4. So we set it up like long division. Always insert. I usually just like to do 2 zeros and I add more if I need them. I'm going to go a little faster here. We need to know our long division steps. If not, use Con or IXI for help. Just search long division. Okay. And once we have no remainder, we stop. So with a terminating decimal, that means it doesn't keep going on and on. It stopped, in this case, with the 5 in the hundredths place. So 0.75. Okay, the decimal ends, it terminates. Okay, make sure you pause and write that down if you haven't already. On the converse, there's a recurring decimal. That means it's not going to end. This is going to keep repeating. The definition we have there is it repeats the same sequence of numbers without stopping. Okay, we have an example there, 4/9, or 4 divided by 9. I already wrote the long division for you there. But one thing you'll notice, if I keep going, say I just did this next step, I still have the remainder of 4. I insert another 0 because I can, I keep bringing them down. 9 goes into 44 times 36. I still have 4 as my remainder. That's a pattern that'll go on forever. You will always get 4 as a remainder. It's a recurring decimal because that 4 is repeating. Okay, this red sentence is important. You don't have to keep repeating the 4s. Once you notice the pattern, you can just simply draw a line over the digit that repeats. So 4/9 just looks like that as a decimal, 0.4. Just make sure you draw the line over the 4. This image is from a movie called Groundhog Day. The plot was this guy woke up every day, would repeat the previous one. He was like stuck in some kind of time loop. So his days were recurring, okay? And that's a groundhog driving the car for him. Okay, let's try to find another example of when the decimal recurs or repeats. 7/11. Again, I'm going to do this division fast because this is not our target. This is an old target, right, of long division. Okay. You might have started to notice the pattern already. Okay, you might be able to see, I'm running out of room here, but if I keep going, I will keep either getting 7 as my remainder or 4 as a remainder. I'm going to keep dividing into 7.00. I'm going to keep getting this pattern 0.63, 63, 63, 63, 63. It'll go on forever. Now we have more than one digit that repeats. So you still have to draw your line, but now you're drawing over the line over 2 digits because they are the repeating digits. Previously it was just a 4, so we only needed 1 4. Now we have 63, 63, 63. So we only need the 1 6 3, but make sure you draw a line over both those digits in that case. Okay, just one more example, and this is a improper fraction. Okay, usually in the past we would turn this into a mixed number, but we also want to be able to turn it into a decimal. Okay, a whole number with a decimal. So 17 divided by 5, right? We're using that division sign as divided by. So let's just set it up like we've been doing. We're going to need 0.00 again because we're going to have a decimal part as our quotient. But now we're going to have a whole number part as well because 5 does go into 17, in this case 3 times. And we just do the same long division procedure. We bring the decimal up into our quotient. Excuse me. Now 5 goes into 20 4 times. And once we have no remainder, you can see my note here. Please put that in your notes as well. Once you have no remainder, you can stop. Okay, so the answer is 3.4. If you had a 0 up there, that doesn't change the value, so either would be correct, either 3.4 or 3.40. They're the same exact value. Okay, so here's your independent work. Please write this down as well as like a heading with the page numbers and everything. And when you do your questions and answers, for example, you do number 2A from page 211. After you write all this information, then you start doing your problems. Please write 2A and then do the problem with the question and answer. Because when we check the work, I want you to be able to easily refer to it so you can see whether you got it wrong or right. So when we get a quiz or a test, you can easily be ready because you're correcting mistakes you might have made during our practice time. Okay, you see some challenge questions there. I would like you to do those, but do the yellow questions first because they will help you build up to the red challenge ones.